Okay, we're moving on with lesson from Unit 3 and Lesson 4, so 3-4. And today we'll be talking about equilateral triangles. You're going to use properties of equilateral triangles to solve for missing sides and angles. So let's go ahead and move on in our discussion about equilateral triangles. First, a triangle is equilateral if and only if it is equiangular. Remember, the word equi means equal. So that means if equiangular means all of the angles are equal. So what we would put here then, for this one here, if the measure of if the measure of angle A here equals or is congruent to the measure of angle B and also equal to the measure of angle C, then we are looking at an equilateral triangle. And this would also hold true that AB, this side, is congruent to BC, which is also congruent to CA. Okay, and the opposite of the converse hypothesis is true. If AB here is equal to BC is equal to AC, then the measure of angle A equals or is congruent to the measure of angle B, which is equal or congruent to the measure of angle C. Okay, it seems kind of straightforward. So that's the first part of equilateral triangles. The second is that all angles are 60 degrees always, no matter how long the side is. So if I have an equilateral triangle like this, at each side, let's say, is 10 here. Okay, these angles here are all still 60 degrees. So here, here, and here. That makes sense because we have 180 degrees total in any triangle. The same is true if I had an equilateral triangle with, let's say, each side was 60 feet long. It doesn't matter. The angles would also be 60 degrees, just like in this one over here. Okay, so just the idea that you always have 60 degrees on every angle in an equilateral triangle. Alrighty. So we're going to get right into it here with a my turn. That's pretty much all there was in terms of note taking on the last slide. So here we're asked for angle C. Okay, so we're told that there's 60 here, 60 here. I know total in any triangle there's always 180 degrees, which this means must be 60 degrees. Well, since we're looking at a 60, 60, 60 triangle, this must be equilateral. Okay, so this is an equilateral triangle. So equilateral. Lateral means sides. Equiangular, well, angular means side, angles. So equiangular would be all sides are equal and all angles are equal. So we're told true then for BC, this side here, well, if all the angles are equal, then all the sides are also equal. 9 feet. And 9 feet. So we can go ahead and answer our questions here. Okay, so BC equals 9 feet, as does AC, which is this side here. Okay, let's move on. Okay, your turn. Let's take a second and go through this one here. Okay, so the first thing that sticks out to me are these little tick marks here, these little guys right here. We discussed yesterday that if there are equal tick marks on each one of those sides, then those sides are congruent. So it doesn't matter what the sides are worth, in this case 24, but the fact that I know that they're all equal. So I'm going to go ahead and label here 24 and 24. Well, if that's the case, then we know that all three angles are also equal, which means they all have to equal 60 degrees. Right? Because 60 plus 60 plus 60, or 3 times 60, is 180 degrees total. So the measure of angle J we're asked for here, well, that's just 60 degrees. K and L are also all 60. And that's how we take care of that. Let's go ahead and move on here. Okay, let's go through my turn again here. If triangle PQR is an equilateral triangle. Solve for x and y. Now, at this point, it gets a little more challenging, the fact that there's nothing given in terms of definite side measures or angle measures. But that's okay, because if it's equilateral, it's also equiangular, which means that all sides, all angles equal 60 degrees. So if that's the case, this angle equals 60, this one equals 60, and that equals 60. But the one I'm care about most is this one, because it's going to help me solve for x. Well, if 7x minus 3 equals 60, I can solve for x, and then substitute my x value into everything else to solve for the rest. So 7x minus 3, I would add 3 to both sides. Okay, I'm left with 7x equals 63. Divide both sides by 7. And x equals 9. So we've solved for x. We're also asked to solve for y. Okay, so let's go ahead and solve for y now. Now here's an issue. The challenge becomes like, well, how do I know what to set one of these three expressions to? And the honest truth is that we don't know a side measure, but we know that these sides are equal to each other. So all I really have to do then, I'm just going to go ahead and create a little space here. All I really have to do then is just set two of these sides equal to one another. So I'm just going to go ahead and choose this side and this side. I could have chosen this as well, but the ones I circled are the ones I'm going to use. So I'm going to say 9y, and try to write a little. So 9y plus 1 equals 11y minus 23. Okay, so let's go ahead and subtract 9y from both sides. And while I'm at it, I'm going to go ahead and add 23 to both sides. So this crosses out, and so does this. And now I'm just left with, and I'm just going to switch things around. So I'm going to put the y's on the left side here. So I'm going to say 2y, right, because 11 minus 9 is 2, equals 1 plus 23 would be 24. Let's go ahead and divide both sides by 2. And y equals 12. And if you really wanted to know what each side worth, just substitute y into any of these values. Okay, so let's say let's try this one here. Okay, so 14 times y, well, in this case is 12, minus 59, and this would equal 109. So this side would be 109. Okay, all right, let's move on. Go ahead and take a few minutes and try this one on your own, please. And it's really important that you try it on your own first so that you know if you're getting it or not. Okay, so this one's a little similar to the last one. We're told if ABC is an equilateral triangle, find x. Well, we've already established in equilateral triangles, all angles measure 60 degrees. That being the case, well, that angle has to equal 60 degrees. So all I have to do is set up this equation, x minus 8 times x minus 44 equals 60. Let's go ahead and add 44, both sides. I'm left with 8x equals 104. Let's go ahead and divide both sides by 8. I'm left with 8 over 8 is 1x, or just x. And I have solved. 104 divided by 8 is 13. So my answer is 13. Okie dokie, and just to make sure, let's go ahead and say 8 times 13. I'm just going to substitute into this expression here. Now we get 8 times 13 is 104. And 104 minus 44, well, that's 60. So it checks out. That makes sense because we know that this angle has to equal 60. Algebra was good. Let's move on. Okay, so solving for sides with algebra, kind of what we were just doing right now. we're going to go on with it. So if triangle ABC is an equilateral triangle, solve for both x and y. Okay, so the only piece of information that we're given here is that 49 is the value of a to b. But if it's an equilateral, this must also equal 49, and so must this, right? It doesn't matter if it's written as an expression. We can go ahead and set up two problems. We'll solve the first one for x. It'll be 3x plus 1 equals 49. Okay, and the other one here, I'll do it in blue, will be 18y minus 41 equals, again, 49, because it's 49 is the value of each side of this triangle. So let's go ahead and do the first one here. So I'm going to subtract 1. I'm left with 3x equals 48. Divide everything by 3. Okay, and I'm left with x equals 16. All right, let's go ahead and do the same thing with the y value. Okay, so I'm going to add 41 plus 41 both sides. I'm left with 18y equals 90. I'm going to divide both sides by 18. And left with y equals 5. And that's how we do that. Okay, so pay close attention. We're given clues. Even though we're given expressions, if we're given one side, we can easily set each one of those expressions to 49 like we did. Solve for x, solve for y, and we're good. Alrighty. Let's go ahead and take a few minutes, put pause, and work this one on yourself. Okay, so once again, I don't know the measure of each side. That's what we're asked to find. Actually, we're find x and the measure of each side. Again, if this side and this side are congruent, well, I can say, well, 4x minus 25 equals x plus 4. That's exactly what I'm going to do. 4x minus 25 equals x plus 14. Okay, let's go to do some stuff. So minus x both sides, and we'll go ahead and add 25 while we're at it to both sides to isolate the variable. Okay, so now we're left with 3x's, 4x minus x is 3x, right? Equals 14 plus 25 is 39. Go ahead and divide both sides by 3. And we'd find that x equals 13. Now, we got the x part. Now we need to find the measure of each side here. So it doesn't matter what value, which side you substitute in, but I'll just go ahead and use this one here. So let's say x plus 14. So x plus 14, I know, instead of saying x, I'm going to substitute the value of 13. So each side must equal 27. Okay, and I'll write the word side. And I could even say or equals NP equals MP, PM, and equals MN. So you may see it written that way as well. Alrighty. So again, moving on to independent practice. You may work your problems by hand in your notebooks if this is easier for you, but be sure to neatly record your answers on the Pear Deck slides. You must show your work and answer for your exit ticket slide at the end. So let's go ahead and look at what the expectation is for your work, independent practice. You'll go through this one here. We're going to find the value of x, number 2, number 3, number 4. This is a fifth problem. Here's a review from 3-1. Remember, today we're doing 3-4. We're on the 4th lesson, so I'm going to review. I want you to review and answer this question from a few days ago lesson. This here was 3-2, the second lesson, so you'll be responsible for these as well. 3-3 was yesterday's lesson in regards to isosceles triangles. Remember isosceles. And then you're left with an exit ticket. See, work must be shown. So work shown. Okay, and then box in your answer. So if M and triangle MNP is an equilateral, find the values of x and y. So at the end, I should have x equals, right, and boxed in, and then I should have y equals and boxed in. Okay, so try to be as neat this is possible, I recommend using the text or typing button so that your work comes out nice and neat. Okay, that's all we got today. Have a great day, and if you have any questions, let me know.